Good day everyone, this is Sir Fred and welcome to another video lesson tutorial. In today's lesson, I'm going to discuss finding measures of position using the Mendenhall and Sincich method. Let us take a look at the following objectives. Illustrate the following measures of position for ungrouped data, namely quartiles, deciles, and percentiles. Compute for quartiles, deciles, and percentiles of ungrouped data using the Mendenhall and Sincich method. And finally, interpret measures of position for ungrouped data. In our previous discussion, I discussed to you what measures of position is all about. When we say measures of position, these are techniques that divide a data into equal groups, namely the quartile, the decile, and the percentile. In our discussion for today, I'm going to discuss the second method of finding measures of position for ungrouped data, and that is what we call the Mendenhall and Sincich method. The Mendenhall and Sincich method is being developed by William Mendenhall and Terry Sincich to find the position of the quartile in a given data. So they are the proponents of this second method of finding measures of position for ungrouped data. Under the Mendenhall and Sincich method, so there are certain formulas for quartiles, deciles, and percentiles that we need to be familiar with. So these formulas that is shown on your screen are different from the formula that we have used under the general method. So we have for quartile, that is k times the quantity n plus 1 all over 4. For decile, that is k times the quantity n plus 1 all over 10. And for percentile, we have k times the quantity n plus 1 all over 100. Wherein k stands for the position of the data or the index, and n stands for the number of position. So remember class that in terms of quartile, decile, and percentile, the value of k matters most, especially on the position that we are looking for in a set of data. There are certain steps that we need to remember in finding for quartile, decile, and percentile ranked under the Mendenhall and Sincich method. Number 1 is for us to arrange the data in ascending order. Number 2, find the rank of the data using the formula for quartile, decile, and finally percentile. And of course, we need to determine the quartile, the decile, and the percentile value. But class, there are some considerations that we need to look after in our solution as well as with the answer that we will get after we have identified the value for quartile, decile, and percentile using the following formula. So I want you to remember, class, the following. So after you have used the formula and identified the quotient for quartile, decile, and percentile, if the quotient that you have obtained is a whole number, directly locate the position of the quartile, the decile, and the percentile in a set of data. I want you also, class, to take note that if the quotient obtained has a decimal value, I want you to remember the following cases. So first, if the measure of position that we are looking for is located below the median, so namely the second quartile, the fifth decile, and the 50th percentile, what are we going to do is to round up the value. On the other hand, if the measure of position that we are looking for is located above the median, so these are second quartile, fifth decile, and 50th percentile, so we are going to round down. So these rules that I am reading right now will be applied on the succeeding examples that will be shown on your screen. That is under the Mendenhall and Sincich method. So let's consider this first example. Consider the following set of scores in a quiz in Math 10. The results were 14, 10, 12, 9, 17, 5, 8, 9, 14, 10, and 11. So we are asked to locate or identify the lower quartile and the upper quartile of the data. So let us apply the methods or steps in finding these measures of position under the Mendenhall and Sincich method. For our first step, we are going to rank the data in ascending order starting from 5 up to 17. So once you have ranked the data, locate the position of the first quartile using the formula k times the quantity n plus 1 all over 4. So since we already have the following values for k and n based on the position that we are looking for, so k here will be replaced by 1, n will be replaced by 11, that's the total number of data, just copy 1. So by simplifying, so 11 plus 1 is 12 times 1 divided by 4, that is equal to 3. So under the method that we have read, if we get an exact value, just directly count this position in our set of data. From left to right, we have 1, 2, and 3. So therefore, the first quartile is the third position, and that is equal to 9. By interpretation, this means that 29% of the scores are less than or equal to 9, while 75% of the scores are greater than or equal to 9. So for the upper quartile, using the same value and after we have ranked them in ascending order, so we are going to use the same formula, that is k times the quantity n plus 1. In this case, the value of k becomes 3. Okay? So now, n is also the same, that's 11 plus 1 all over 4. So by PEMDAS rule, 11 plus 1 is 12 times 3, so that is equal to 36 divided by 4, the quotient is equal to 9. So since we got an exact value, so we are going to directly locate what is the ninth position in our set of data. So by counting, the value of the third quartile is in the ninth position, and that is exactly equal to 40. By interpretation, class, it means that 75% of the scores are less than or equal to 40, while 25% of the scores are greater than or equal to 40. So let's have this second example. So find the quartile 1 and the upper quartile as well as the interquartile range of the given data. So we have 19, 13, 3, 10, 15, 20, 18, 10, 12, 13, 16, and 17. So for class, the first thing that we need to do is to arrange the data in ascending order. So we are going to use the formula k times the quantity n plus 1 all over 4, and this formula is under the Mendenhall and Sincich method. So for quartile 1 class, so just substitute the given from the problem. So k is 1, the total number of data is 12 plus 1 all over 4. By simplifying it, that results to 13 over 4, and the quotient of 13 divided by 4 is 3.25. So class, under the rule that I asked you to remember, so observe that the value that we get is a decimal number. So since it has a decimal number, so locate the position of the quartile. Okay, is it below 50% or the median, or above 50%? So as we all know, class, that quartile 1 falls below 50%, and that is the median. So therefore, under the rule, we are going to directly round up the data. Okay, by rounding up, 3.25 results to the 4th position, and by counting, the 4th position in our set of data is equal to 12. So now let's take a look at the third quartile. So here, k will be replaced by 3 times the quantity 12 plus 1 all over 4. By simplifying, we get 39 divided by 4. The quotient of 39 divided by 4 is equal to 9.75. So in this case, class, we also get the same decimal. Okay, the number that we get has a decimal value, comparing it to the first quartile that we get. But locate the position of the data that we are looking for. Is quartile 3 falls below the median or 50%, or is the third quartile falls above 50%, which is the median? Okay, so as we all know, class, that quartile 3 is 75%. So therefore, that is above the median. So under the rule, we are going to round down. So therefore, from 9.75, applying the rule, that is equal to 9th position. Okay, by counting, the 9th position in our set of data is 17. So therefore, 17 is the third quartile and 12 is the first quartile. So we are going to use that in our interquartile range. So we get the difference of quartile 3 and quartile 1, that is 17 minus 12. The result is equal to 5. Okay, class. In our third example, the score of 12 students are as follows: 15, 13, 20, 16, 14, 19, 15, 19, 11, 10, 18, and 9. So we are asked to identify the positions of the first, the fourth, and the 9th decile. So before we proceed, class, observe that the examples that I am using or presenting to you right now are the same set of examples that I used under the general method. So don't be confused of the values that we will get, because sometimes the values that we get are different depending on the method that we are going to use. So it's up on your instructor or your teacher on what method are you going to use to identify the positions of the following. So in this case, class, we are going to arrange the data in ascending order, and afterwards we are going to use the formula for the decile as shown on your screen. So for the first decile, so k will be replaced by 1. The total number of data is 12 plus 1 all over 10. That is equal to 13 over 10. Getting the quotient of 13 over 10, that is equal to 1.3. Okay, class. So it has a decimal value. So locate the position of the first decile. Is it below the median, which is 50%, or above the median, which is 50% also? So what do you think, class? So as we all know, that first decile falls below the median. So that's 10% of the distribution. So therefore, under the rule, we are going to round up the data, and that is equal to the second position. So by counting, the second position in our set of data is equal to 10. Next is the fourth decile. K will be replaced by 4, and upon simplifying this expression, that's equal to 52 all over 10. Getting the quotient of 52 over 10, class, that's equal to 5.2. Okay, so it has a decimal value. So locate the position of the decile that we are looking for. Is it above 50%, which is the median, or below 50%? So as we all know, class, that the fourth decile is 40%. So that's below the median. So we are going to round up the decimal value that we get, and that is 6th position. So by counting, the 6th position in our set of data is 15. And finally, class, for the 9th decile, that is 9 times 12 plus 1 all over 10. So that is equal to 117 all over 10. Getting the quotient of 117 over 10, that is equal to 11.7. So comparing the value that we get in the first as well as with the fourth decile, the 9th decile has also a decimal value. But take a look, class, of the position that we are looking for. Is it below the median, which is 50%, or above the median? So as we all know, class, that decile is 90%, okay, of the distribution. So therefore, that falls above the median. And by the rule that we read a while ago, ignoring the value of the decimal, we are going to round down. So by rounding down, that results to 11th position. And therefore, the 9th decile is equal to 19. So, and finally, class, for our last example, the score of 12 students are as follows. We have 15, 13, 20, 16, 14, 19, 15, 19, 11, 10, 18, and 9. So we're going to locate for the 40th and the 65th percentile. So we are going to arrange the data first in ascending order, and afterwards we are going to use the formula for the percentile value under the Mendenhall and Sincich method. So as we all know, class, that for the 40th percentile, we're going to replace k by 40. That times the quantity 12 plus 1 all over 100. So that thing applies to the 65th percentile. So we have 65 times the quantity 12 plus 1 all over 100. So next, by simplifying the expression, so we have 520 over 100 for the 40th percentile and 845 all over 100 for the 65th percentile. And the quotient that we get for the 40th percentile is 5.2. So as we all know, class, Whenever we get a decimal value, we are going to directly locate the measure of position. So where does 40th percentile located? Is it below 50%, which is the median, or above 50%? So as we all know, that's below 50% of the distribution. So therefore, we are going to round up. And by rounding up, okay, we directly get the 6th position in our set of data, and that is equal to 15. So therefore, class, the 40th percentile in the set of data is equal to 15. So meanwhile, going back to the 65th percentile, we get a decimal value also, which is equal to 8.45. So since we get a decimal value, so we are going to take into considerations locating the position of the 65th percentile. Is it below 50% of the distribution, or is it above 50%, should I say? So as we all know that 65th percentile falls above 50% of the distribution. So according to the rule, we are going to round down the data, ignoring the decimal value. Okay, so the position now of the 65th percentile is in the 8th position. So by counting, the 65th percentile here is equal to 16. Okay, to wrap up the things that we learned for today under the measures of position using the Mendenhall and Sincich method. So, okay, number 1, arrange the data in ascending order. Number 2, find the rank using the formula for quartile, decile, as well as with percentile. Okay, so next, determine the value of the quartile, the decile, and the percentile. So we have things to remember. If in case that the quotient we get is a whole number, we directly locate the position of the measures of position. But in the case that the value obtained is a decimal, so we are going to identify the position. Is it above the median or below the median? But in letter A, if the position is below the median, we are going to directly round up the data. Okay? And if it is above the median, we are going to round down the data. So take a look, class, at our median for quartile, decile, and percentile. So this will be your guide in identifying the measure of position if we are going to round up or round down depending on the situation. If it is a decimal, so we're going to apply rule number 2. And if it is a whole number, we're going to apply rule number 1. So, and by that, class, so thank you for watching, and please don't forget to click the subscription box and notification bell to stay updated. See you in our next video lesson. Goodbye!